So assignment number 2, measurement. Oh, that's funny. So you click on it. I did a PDF and a Word doc, so you have them both. You can complete this assignment in one of 2 ways, because I know some people are definitely not as comfortable with technology. I don't want to say technology in general terms, but like the kind of technology that we use in this class yet. So then, you know, well, what do you do? You know, like you just failed. No, you got to have a different approach, right? So you can print it and find the measures using a ruler and a protractor, or you can go to the Desmos link and perform the measurements digitally using the methods discussed in class. So I got to discuss those methods, right? And this would be the Desmos link to access. So you click on that, and you get the UK map. And if you zoom in, you see it's got a little.
You said who?
Sorry,
Don't stress yourself out.
Okay, that scared the living daylights out of me. So we have the scale factor, the scale map, right? So we can use that to do some conversions, but you still need to get the measurement, right? So I'm going to walk you through a similar problem just so you have it. But if you are working with the actual document, the image is included there anyway, you know. So and also it just popped out at me at this very moment that for whatever reason in the Desmos that scale, the key didn't really come out very clear, but in this one it's pretty crystal clear. So so we're good to go there. Right? So you kind of work with both of them. I gave you a couple of I gave you a ruler and a protractor. So if you wanted to, you can cut these out. You know, like if you're going pencil paper, if you're actually going to print this out, you just cut these bad boys out and just use them to create your measurements, right? So, but I'm going to show you how to do it on Desmos because I think the by hand approach is probably going to be pretty straightforward, right? But I'm gonna show you with a similar example. You know, I'm not going to do this exact one. I'll just do it with a slightly different one, right? So what you'll have to find is the approximate distance between Dublin and London, right? Line segment, you draw the line segment from Dublin to London, then from London to Edinburgh, then back to Dublin, then measure the length of each line segment using the ruler provided. And then using the scale in the map, find the approximate distances from Dublin to London, blah, 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 right? It's at this moment that I realized that this is a dumb question because it's being addressed down here, right? So, hey, typos for everyone. So you can get rid of number 1, it's just 2 through 5. What are the measures of the angles created by the line segments at each city? So I'll walk you through that also, right? If you're doing it if you're doing it by hand, then you just take a picture of all your work and pop it up on Blackboard. If you're doing it on Desmos, then you just have to create a share link, right? So let me show you what I mean by the Desmos stuff anyway. I'll get an edited version of this up. I'll try to do it tonight, but I'll probably forget and I'll end up doing it tomorrow. But somebody will get some typo bonus credit for pointing out this typo. And again, I point them out in class. That means nothing. Right? That doesn't mean you can't submit it because I'm going to forget immediately that there's a typo here and never do anything about it. I've had some typos in note packets for like 20 years. I just never change it because I keep forgetting. Right? So that's kind of an issue. But anyway, so let me show you the similar example. I just got to open it up. The Google. Oh, let's see here. My example, I did a US map. Open the graph. All right, and I got the same dumb example here. So we'll go, in this case, I'm going to draw a line segment from LA to Phoenix, then from Phoenix to Denver, and then back to LA. All right. So in either of the Desmos activities, you have a protractor, and it's an interactive protractor and an interactive ruler. All right. So whether it's my example here or the actual activity. All right. So again, if we go to the activity itself, you have a ruler. And so if I go into the ruler folder, and in order to access it, I hit that little drop down. XO controls the horizontal movement. YO or Y sub 0 controls the vertical movement. So you see if I slide this slider left and right and move the ruler left and right, I don't really want to be looking at the protractor right now. So I would click on the protractor folder to make that disappear. Now I have a ruler that can move left and right. I have a ruler that can move up and down, and I can play around with the orientation. Okay. So, and it'll go in a full circle. So you can get what you need out of that. But let me show you on the example case. So I'm going to draw a line segment from Los Angeles to Phoenix. Right. So in my graph, I got to find LA. Right. And it's marked off in there. It's just kind of tougher to see. But here's LA. Here's Phoenix. I want to draw a line segment going from there to there. Right. So what I can do is I can try plotting some points and doing that whole polygon thing I showed you before. All right. So the way I do that, and again, we're not really at the point where we need the ruler and the protractor just yet, but I would just plot some kind of point. It doesn't really matter. I'll plot 0, 0. And you see that puts me right in the middle of Kansas. All right. But then I can kind of move it around from there. Right. So that point is 0, 0. Right? And that's a good benchmark to start with. But I want to be able to kind of move it over, up and down, left and right to get it over to LA. All right. So there's a couple of ways to do that. One, if you long press on the point, you see an option to drag. You can drag that point wherever you want. I want to drag it over to LA. All right. So this point, I would call point A, A for lack of a better term. So A equals all of that. And then just to kind of drive that point home, I'll pop an A on the graph. Now, it can be a little tough to see, so you can zoom in if you want, but you shouldn't have to zoom in a ton just to see a point, especially since it's kind of blending into the background. Anytime you want to make an adjustment to the characteristics of a point, so I got my LA, I think I had it at the wrong location, like right here. Right? If I want to change a characteristic, I can long press on the icon in that, like where the numbers are on the side there, where it says 16, 15, 10, whatever. Like in that grayed out little field there, long press, and I can change a few things. One, I can change the color. That's helpful. Right? If I get it something a little bit more obvious, maybe it'll stand out. Right? Then there's also the opacity. Right? I can change that around too. But I can also change the size of the label. Right? Where it says A1, that's saying that's the default size of the label. If I want it to really stand out, make it something obvious. So I'll make it a 5. What's 5? I have no idea. No, I believe it's a scale factor of 5. So 5 times whatever the indicator originally was. All right. So now I have LA plot. All right. That's my point A. I need Phoenix. So I just do the same thing again. I grab another point and just drag it on over. But see this little gear icon. And by the way, I'm recording all this, folks, so you can have another look at it later, but you can also ask questions too. If you hit this little gear icon, you see that there's an option to duplicate. It'll create another point. at the exact same location. Well, I don't want it at the exact same location. So I'll hit done. And I don't want it to be the same point. I'll change that to a B. All right, so now it's the same point, but just called B. But I can also just drag, well, I don't want to drag that one, drag my point B to Phoenix. All right, and then we could do the same thing again, but you could also just do it the same way we started. I think the third point was Denver. Yeah, I got to get over to Denver. But what I could do, I could plot the point 0, 0 if I want. But kind of just start from scratch. It'll put me right back in the middle of Kansas again. But we long press, change the color. And then mouse is kind of terrible. Change the color, make sure the drag is on, you know, and you can go that route. Lost it, trying to scroll. Get our label, make it something like 5. Right. I don't really need it to be plotted as 0, 0. So I just make sure I type it, because that's the thing. If you don't put in something under label, it just puts the coordinates in the monstrously large size. So I'll just call that C. It still has it plotted in Kansas. I don't want it in Kansas. I want it in Denver. Okay. So now I have my 3 locations. So what I would do is create a polygon, because the directions say draw a line segment from really A to B, B to C, and from C back to A. But if we use the polygon function, not type. Now, just a word on that. Before I showed you that what I was doing to bring up the polygon function, that was going into the function menu and then scrolling down to geometry and seeing the one that says polygon. And that's a great way to do it. But if you know that a function exists, you could just start typing it in. It'll start typing it in as italics, and it'll start asking you if you want a slider and all that stuff. It can be a little confusing at first, but once it recognizes it as a function, a programmed function in Desmos, it goes from italics to ordinary font, and then it recognizes it as a function. So open parens, A, comma, B, comma, C. I can get rid of this stuff. I can close the keyboard. Now I have that triangle representing those 3 locations. And so all that area would be the triangulation. So we have what we need. We have our line segments drawn, but I still need measurements. All right. So what I would do is I'd use my ruler and just start measuring, but then I'd have to do a conversion. Right, the conversion's a little, it's computation intensive, but I'd also be making sure that I'm saving all of my work as I go. It's really not a big deal. It's if you forget to save it, then you go do something else and come back to it 24 hours later, it's almost always still there. It's when you close out the tab and you didn't save it, that's when you have a heartbreaking situation on your hands. So hit save, that's easy. But if it's untitled, you'd hit the little drop down, give it a title, rename, call it whatever you want, and then save it. All right. So then I need my measurements. So I'm going to bring my ruler into the conversation. And by the way, if you're doing this on Desmos, your Desmos is your work. All right, that's the beauty of doing it this way. So we would want to use all of these fields to represent our answers. So I want the ruler. So we have 2 folders, one with the ruler, one with the protractor. I'm going to turn the protractor off just by hitting or clicking on the icon associated with the protractor and just focusing on the ruler. All right. Hit that little triangle is how you open the folder. right? Little folder icon, little triangle, tap that, click that, and now you have the XO and YO controller, right? So I want to bring this over. I want to bring it down and I want to rotate. And it does take a little bit of patience to get there, but you know, you can just kind of go, you know, do your best. You might have to zoom in a little bit to really see what's going on. You know, so you get close and it's like, it's not quite there. Although you could probably figure that this is going to be 4 centimeters, but I want to be absolutely sure. So I'm going to bring it down a little. I'm going to bring it over a little. Alternatively, you can also drag it. You just got to find the drag. Yeah. So it might take a little clicking to get there. But once you do that, you can get to where you need to go. And then when you drag it, you see the numbers are adjusting on the slider accordingly. You see my angle is a little bit out of whack here, so I want it to be just a smidge more. All right, and so if it doesn't line up perfectly, you could be in for kind of sort of a rough go with it, but in almost all cases, it'll line up at least close enough that you can get a good measurement. So here it's close, but I'm still not in love with it. So I can, unfortunately, dragging is only going to either expand the size or move it around, right? It's not going to, on Desmos, you see there's no rotation option, right? So it's a matter of precision over here. So when I look at this and I say 6.07 is close but not close enough, 6.1 is close but not close enough, I'm thinking it's somewhere between these two numbers, 6.07 and, come on, well, 6.1 anyway. So somewhere between 6.07 and 6.1, you can actually just type in value. So maybe I'll try 6.08. That looks pretty good. All right. So you line it up again. Now we have a pretty good fit there. Right. Now I want to get a good look at this so I can get my precision. So I zoom like the Dickens here. And so if I'm in millimeters here, I'm going 1, 2, 3. Now our precision is 1/10 of a centimeter, 1 millimeter. So I have 1/10, 2, 3, 4, 5, 6, 7, 8 tenths. All right. So 3 8/10, I would make a note of that. All right. So the measure. Now, if you want to make a note, there's 2 ways to do it. One way would be to hit this little plus icon, and you'll see an option for a note. Do that. Or you could just open a set of quotes here, and that automatically does it. All right. So then I would say, just a quick shorthand measure of AB is 3.8 millimeters, centimeters, right, based off of this rule. All right. We'll have to get a conversion there too, but for now, we're just taking note of what the actual measurements are. All right. So I need B to C. So I'm going to rotate. I can drag or I can use my sliders to get it up into the right neighborhood. I might have to zoom back out. If it looks like the line in your ruler is parallel to the line that you're trying to measure, then you're good. But you can see here that we have a little bit of a gap here, but then less so. So I think I need some more rotation. That looks pretty good. Ah, I had it. So around 3.9. And so I'm going to bring it back in, and I'll just do some dragging. But again, you got to find that sweet spot there. I got to get it on the 0. Yeah, that looks pretty good. So 6, and then we have 6/10 after that. All right, so 6.6 going from B to C, or C to B, either way, same distance. All right. So measure from B to C, 6.6 centimeters. And then we just got to get that last segment there. Now, if this were something like a right triangle, then you could use some algebra. You're familiar with the Pythagorean theorem, you could do that. But this is not a right triangle. So I make mention of this because in the past, people would say, oh, we could use that to figure it out. I'm like, if only, that'd be nice. But nope, we're measuring. Okay, so I got to get my angle. Looking for that parallel relationship. If it's not perfect, I'll tweak it a little bit, but hopefully it won't be a case like that first one where I have to go too crazy with it. But it looks like it's pretty good. I mean, it's a little off over here, but you know, not in such a way that you're like, well, it's going to be completely incorrect. I mean, if anything, maybe it just adjusted by the tiniest of smidges, so like 3.58. Actually, the other way, 6, and that gives you a better fit. So this looks like it's 9.4. So going from A to C is 9.4. And you see what happens when I forget the quotes. It makes it look all weird, like an asking for sliders. And so quote measure from A to C is 9.4 centimeters. I think I said 9.4. Yeah. All right. So we have all those measurements, but we do know that if you get in a car and drive from LA to Denver, you're going to drive a whole lot more than 9.4 centimeters. So we know we have to do a unit conversion in order to get the real answer. But this is a good start. The angles, though, we don't have to do a conversion in order to figure that out, right? Which is good news. So then, based off of the same size and orientation of your ruler, we now need to get a sense of what these values mean, right? So if we're going miles, you know, because the directions, you know, sometimes they're specific. In this case, it's saying in miles, right? So you got to be mindful of what the question's asking you to do, right? But I'm going to take my ruler. Oops. I'm going to spin it around. I'm going to drag it down and just get an idea of what the conversion factor is going to be. All right. So I want to make sure it lines up pretty good. If it's not, again, I just do a little dragging. It's just the one thing I haven't quite figured out with this is how to get it to activate the ruler without having to hunt around looking for it. But you do have to kind of click around to try to find it. But it looks like, you know, if we could get a clean relationship, that'd be preferred. But it looks like 300 miles is about 3.4 centimeters, right, in this case. But if you look at it, you know, it's almost a match between 0.5 centimeters and 50 miles. That would have been a nice conversion factor. But then you can see that 100 miles is a little bit off, right? So 300 miles is, you got to kind of squint and blur your vision, but that looks like it's about 3.4 centimeters. So 300 miles. corresponds to 3.4 centimeters. Right. What I would want to know is what 1 centimeter is worth. Right, in terms of miles, because then I can determine those distances using that information. Right. So the way we would handle this is by dividing 300 by 3.4, and that'll tell me what 1 centimeter is worth. Right? And then we could use that as a multiplier. Right. So we're looking for what's called a unit rate. Right? And that's dependent on whatever the scale factor is. Right? So very quickly, let me show you that. I'm just going to scratch out the computation for you real quick. It's just so you know why we're doing what we're doing, rather than me being like, oh, just do this. Why? Because I said so. That's why. No, I don't want it to be like that. So it's very simple algebra. It's not anything too complicated. I never wanted this course to be about algebra skills, although, you know, it's kind of fun anyway. But let me pause the recording and bring you over there for a sec. So to get the conversion factor, I could figure out the value of 1 mile in centimeters, or I could figure out the value of 1 centimeter in miles. It actually makes more sense because all of our measurements are in centimeters to determine what 1 centimeter is worth. Right. So what I would do here is look at this as 3.4 times 1 centimeter. All right. 3.4 times 1 is the same as 3.4. All right. That's the whole precision thing. When I say 3.4 centimeters, I'm saying 3.4 increments of 1 centimeter. Right. That's equal to 300 miles. But I only want to know what 1 centimeter is worth. So what I would do is divide both sides by 3.4. Because honestly, I mean, if I want to be specific about this, 300 miles is really 300 1-mile increments. So 300 times 1 mile, well, 1 mile. So when I divide, I'm really just dividing the numerical values. So I would divide this side by 3.4 also. So I would take that 300 and divide it by 3.4, right? So then I'm looking at 300 divided by 3.4 as my scale factor, and it ain't pretty. Look at that disgusting decimal, right? If I tap on the fraction icon, I get something a little bit more appealing, right? But this tells me a little bit more about what 1 centimeter is worth on the map, right? So we would get from this that 1 centimeter is equal to, well, I would have to say 88.235.2941176 miles. Because again, we're not looking around here. Or I could say it's worth 1,500 divided by 17 miles. I think I like that a little bit better because obviously I'm not worried about the round. Right. So that would be my scale factor. All right. So then that's actually my multiplier, because if I know that a certain distance is, let's say, 3.8 centimeters. So for 3.8 centimeters, I don't know why I underlined before, 3.8 centimeters, I know that each centimeter is worth 1,500 divided by 17 miles. If I'm looking at 3.8 centimeters, that's the same as saying 3.8 1 centimeter increments, right? And we know that 1 centimeter is 1,500 over 17 miles. Then I would take my 3.8 and multiply it by that number, and that would give me my distance. All right. So 3.8 times the fraction 1500 over 17. So that's telling me for my first distance in the example that 3.8 was LA to Phoenix. We're looking at 335 point, I mean, it's a disgusting decimal, but 249, not 249, geez, 294, 117647 miles. All right, that's a lot. That's a pretty fair amount of writing that we don't want to have to do, right? Especially with the rounding. Right? I mean, it's really like the lack thereof of rounding. So it's like, how can we streamline this? Well, in Desmos, we can streamline it because we can just leave the computation there and just put a label on. And just checking the chat here. Oh yeah, the attendance. Yeah, that happened in the beginning. Yeah, generally, if when it comes to attendance, if you miss attendance, we talk at the end of class, and I get that taken care of for you. So let me go back to the other screen. I know this is annoying, but it is what it is. Resume. All right. So we now know that the multiplier, I know it's off camera now, of 3.8 in order to get it over into miles would be 3.8 times the fraction. I showed it on the other screen, but 1500 divided by 17. All right. Now, we can organize our work here pretty nicely because I have it labeled as the distance from A to B, but if I look at my diagram, the way I have it marked up here, A to B is LA to Phoenix. So what I can do right after polynomial, wrong course, Polygon, I can hit enter and that'll open a new field. So I can just title this using open quotes, LA to Phoenix. Not phonics. Okay. And so this would be the distance in miles. Right. So what I would do here is take this, I would just do a copy paste job, get that, because I have my computation here. I would just paste this in and just type in miles afterwards, but do it as a note. Right, so now everything's in the LA to Phoenix category. So then the next one was Phoenix to, you can drag blocks around too. So when you do what I just did and accidentally hit enter in the wrong spot, you can drag the blank field to wherever you need. Phoenix to Denver. So we have this distance here by the ruler, but it's really going to be 6.6 multiplied by 1500 over 17. So I can either duplicate this or I could just do a copy job. Control C, Control V, the Mac, Command C, Command V. All right, change this the 3.8 to a 6.6. And now we say that there's 582 miles separating Phoenix and Denver. All right. Now, the computations are sound. So if these numbers are not right, I've never driven from Phoenix to Denver, but if these numbers aren't right, it's because there's something wrong with the map because we're doing all the computations right. Right. So it would be this number of miles. And then the last piece was Denver to LA. So again, computation, we have our scale factor. The 6.6 gets changed to a 9.4. Copy paste is our best friend. All right. Control C. paste it in there, miles. And then really this scale factor, you can put it anywhere. But you could also just put it down at the bottom. If you're into miles, you put 3.4 centimeters. And then, like we already know the 1500 over 17 is the conversion factor, but you could be explicit about that and say 1 centimeter is equal to 1500 divided by 17 miles. Just little notes to help the reader understand what it is you're trying to say, right? And it's all lots of work. And I'll make this file available to you afterwards, just so you know, in case you're wondering. But yeah, there's a fair amount to it. It's a little tricky, but the tricky part of it doesn't really have to do with the measurement and the computation. It has to do with understanding how to use Desmos, which does have a learning thing, right? So it takes a little while to get used to, but once you do, it becomes very user friendly. So we found the approximate distances in miles. Now we want to know the angles. It's like, oh, wow, I thought we were done. Almost. So for that, we need a protractor. So I go back up here. I'm going to close the book on the ruler, but open my protractor. All right, you see it's down there at the bottom of the screen. All right, open the protractor. It's still the same XO, YO to move it left and right, but we learned from the ruler we don't really need those sliders. We do need to control the angle though. All right, so that A value, so these sliders in the ruler still work for the protractor also. All right, they give you the rotation, they give you the left, right, the up and down, the left, right, the up and down. But we now know that if you just hunt around clicking on it somewhere, eventually it's going to give you the option to drag. All right, so it's just sometimes a little bit more complicated than you want it to be, all right, obviously. But worst case scenario, you use your sliders. So we'll start off with angle A, or the angle at A. I'm going to bring my slider over. Yeah, I'm hunting around and I'm still not getting it, so I'm just going to live with the sliders here. I'm going to bring it in pretty good so I can actually see what's going on. All right. I want to have the center of the protractor on my angle and the line at the bottom on one of the sides of the triangle. All right, so I'm going to bring this up. Now, if you slide your slider all the way to the end and it's like, oh, I can't go any further. The bounds of the slider has a low bound of -10. You can always change that low bound. You can change this number to whatever you want. So let's say I want that to be a -20. It'll extend the bound. So you're not limited to whatever the slider's boundaries are. All right, but I want to get that right on that little corner there. All right, and then I want to rotate it over. And then I'm just going to take note of what that angle is. So kind of tough to see, always tough to see, but you can see the dial starts off at 0, 10, 20, 30, 40, 50, all the way around to 180. And then it goes the other way on the outer edge, right? So I wouldn't count this measurement here. I wouldn't count this as like 144 or whatever, because that would be all of this space over here in this angle, right? I want the angle going from this line segment here, sweeping through this region. So I'm looking for that inner dial, right? So if I'm counting up, I got 10, 20, 30, 30 something, it's still 10 tick marks in between each decade of degrees, right? So 31, 2, 3, 4, 5. It looks like 36 degrees. All right. So that gets me to this other side. Now, that was, I mean, it's off screen, but that's angle C. I'm sorry, point C, CAB. The angle symbol is not going to come up using the note feature on Desmos. So let me just show you how you would write that. All right. So for the angles, make a little note here, angles, we have CAB, right? So what I would do is I would just use a less than symbol, or I would go into my keyboard and grab that, use a less than symbol. You know, sometimes you can copy and paste a symbol from like a different website in, but it doesn't always take it. So I would say angle CAB. It's going to give you this error message, but that's okay. Right. So it's the measure of angle CAB is equal to, I already forgot, 36 degrees. We always have to have the units. So the way we can represent units is by using an exponent and putting the letter O there. It makes it italic, so it looks weird, but that's fine. You put the number 0, but that looks just as weird. Or if you don't want to do that, understandably, just type in the word degrees. All right. So CAB is 36 degrees. Now that is the angle at LA. All right. So that's the angle at LA. All right. Because I mean, it would be a little bit more complicated to write the angle starting at Denver, going through LA, and then ending at Phoenix. That's a nightmare. We don't want to write that. Right. So then we would say the angle at Phoenix. So that's ABC. So measure of angle ABC, which we don't know yet, but we'll get it. Zoom out a little bit, but then we got to do our rotation. Oh, you know what? Honestly, I regret doing that. Okay. So I could actually just slide this graph over, or the protractor over, because it's already lined up. Right. So it's just a matter of getting it over and down so that it's on the vertex or the coordinate point at B. Right. So it just takes a little doing, but you get there. Almost. See, sometimes it hops. You know, you try to get it to land on a point and it just doesn't want to. So you just type it in, like -7.6, for example. That's a little too much. Maybe it's 5. No, going the wrong way. So let's say like 7, 8. 8 is really where it's at. So now it's just a matter of measuring that angle. So it's going from 0 degrees, sweeping through 60, 70, 80, 90, 100, 110, 120. And then we have 1, 2, 3. I already lost it. 1, 2, 3, 4, 5, 6 more degrees. All right. So 126 degrees. Now, the last angle, that would be the angle at Denver. You can do that one of two ways. And this is regardless of whether you're doing it on pencil or with pencil paper or on Desmos. And in fact, in a lot of ways, I've done a lot with Desmos in different classes. And sometimes my demonstrations only push people further towards the pencil paper approach, where they're like, now I really don't want to do it with Desmos. And I understand it's a weird platform, but it's kind of cool. You know, it just takes a little bit getting used to. a dinosaur national monument. I did not know that existed. I might have to check that out at some point. So the angle at Denver you can get by measuring or subtraction, right? And that's because there's 180 degrees contained within a triangle, right? And this is a triangle. So the angle at Denver I can get by taking the two angles I know, 36 and 126, and subtracting them from 180. Right? So you'd really only have to measure two of the values. Right? You'd have to use a protractor to find two of them. And since they share an adjacent side, it should be a little easier because you just slide the protractor along. Right? So the angle at Denver is going to be 18 degrees. Right? Now, maybe you don't want to do it that way. Maybe you do want to do it that way, but you don't want to have to like worry, so I got my measure of angle. What do we call this? ACB or BCA, I could say. Is equal to 18 degrees. Yeah, so you want to be really sure that you didn't just screw it all up. So then you can grab your protractor and drag it over, rotate it, drag it over. You got to get it to match up on the side here. All right, so sometimes you got to take the long way around with the rotation, but you get there eventually. And then you just kind of get in there and just try to get it lined up. I need it up here a little bit. Oh, it jumps on you when you really zoom in. All right, so I'll make this like 5.7. Make this like a 7.1. Still need that angle. Maybe it's like 0.75. Yeah, there we go. It lines up pretty good. Oh, actually, it's a little low though. I need to go higher. And then over. Yeah, there it is. Pretty good. And then when you're measuring, it's just a teensy tiny little bit off. You see the line here doesn't match with the purple perfectly, but it's pretty close. And you can see that the angle is pretty close, 10. It's like just a shade less than 19, but then it's also a little bit off over here. See, there's a little deviation there. That's probably the amount of deviation that it would take to get you back to the 18. So my guess is that if we rotated this a little bit more, then we would get a little bit closer to the true value. But that's the thing. There's going to be a little bit of variation when you do measurements, just because there's the human error part of it, like where you make a mistake. Hopefully that's not going to happen too frequently. But there's also the part of it where it's like, I don't know, is that like 36 degrees, 37 degrees? All right, I'll just use my best judgment. Then there's a cascading effect of the error throughout. It's not anything that would cost you any credit, but it's stuff that you might look at and say, I'm not 100% sure what's going on. Right. So, but that's the assignment. All right. So measures of the angles at each city. I have it all in here in Desmos, along with the line segment distances and the conversions. So I'll save this. I'll get it posted. In a lot of instances, people are just going to go through and like, okay, I'll copy this. I'll put this in there. I'll change that number. I'll copy that. I'll put that in there. I'll change that number. So if you want to do it on Desmos and format your answers just like mine, then you're looking at a perfect score, right? If you want to go with the pencil paper approach, that's perfectly fine too. I'm not going to look down at people because they're doing it with pencil paper, because like I said, this stuff is a little tricky when it comes to Desmos, right? But you're actually going to be physically measuring and doing the computations. and physically rotating your protractor and all that good stuff. All right. So, so yeah, that's that. Now, to create a share link, once you have it saved, you have that little share graph. Click on that, you'll see a share link. You copy that. You just pop that right into the assignment field. You know, you're in unit 1, you're doing your work, and it's like, I did it all in Desmond, so proud of myself. Now, where do I submit it? You go right into write submission. Oh, I didn't want to click that. And then just paste it right in there and then submit. And that's it. I click on this. I look at your work, compare it to mine. I see that you did everything right, and I give you a perfect score. It's a win-win for everyone. All right. This one, again, like every time I make a new assignment announcement and do an overview, you'll have 2 weeks to complete. All right. So let me stop the recording.